Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into how to solve little equations for a particular variable. And let's understand something here. A little equation is one with multiple variables. We call it a multivariable equation here, where we want to solve for a particular one. So take a look at our goal right here. It sounds simple, but it's challenging for most students. For example, let's take a look at this first one here. We got the famous Einstein equation, E equals mc squared, and we want to solve for m. Highlight it here. Oh, and by the way, take out your red pens, okay? Uh, I use color to emphasize things, and I use red a lot. So use red pen to annotate, and you'll see that it's going to be useful to highlight the important things, and also take out a highlighter too, always in my lessons here. So let's go for it here. Let's take out take E equals mc squared. Over here on the right, we're going to show the entire process on the right side. The problem itself is on the left. And here we're going to solve for m. Now, Einstein, in the Einstein equation here, E didn't stand for Einstein. It stands for energy, actually. And energy is equal to the mass, m stands for mass, times the speed of light squared. C is actually the speed of light. Einstein came up with that many, many years ago. And unfortunately, he's not alive today, which is a bummer because I would have loved to meet the man. He's just a brilliant mathematician and physicist. But anyways, we're going to solve for the variable m, and m is right now it's being multiplied by c squared. And you have to understand it's being multiplied. mc squared is m times c squared. I'm going to write it like that. And the reason why, put a dot there, is because you have to understand that mc squared stands for m times c squared. And a lot of people don't even realize that. And if you realize that, and you understand that in algebra we always do the inverse to solve for a variable here, then this is actually fairly straightforward. When I see that m is being multiplied by c squared, I want to do the inverse. So take out your red pen, and let's do the inverse of multiplying by c squared, which is dividing by c squared. So divide both sides by c squared. And we understand that c squared divided by itself is nothing more than 1. Just like 5 divided by 5 is 1, negative 2 divided by itself is 1, x divided by x is 1. We know that c squared divided by itself is 1. All right, those are basics. So this is 1 here, and what do we get? Well, we get energy divided by speed of light squared equals mass, or E divided by c squared is equal to m. Or if you want to switch the order, m equals energy divided by c squared, or speed of light squared. You can go ahead and switch the sides of the equation as you want. Okay? Now, if we wanted to solve for the c variable, let's go on the left to do that. If we wanted to solve for, in this case, c, well, it'd be looking different, wouldn't it? So what I want you to do is pause the video here, do the action on the right, take E equals mc squared, or m times c squared, and try to solve for c. And throughout the video, I'm going to ask you to pause, okay, and play when you're ready. This is an interactive video, so pause and play, and take yourself through the video. Pause right now, go ahead and try to solve for c, the variable c now. Okay, now we're back now, and hopefully you divided by m because it's multiplied by m. We want to solve for c, so divide by m on both sides. And you get E divided by m now, the mass, is equal to c squared. And we're almost there. C is being squared, but somehow we got to figure out how to, isolate c and cancel out your exponent here. So what we need to do is understand the inverse of squaring. And if you understand that, well, the inverse of squaring is called square rooting. So we square root the left and the right. Square root both sides. When that happens, the square root cancels out the square, giving you c, and that's equal to the square root of E divided by m. Notice our answers look different depending on the variable that you choose to solve for. Okay, on the right we solve for m. On the left we solve for c. Okay, let's try it again. Let's take the second equation, d equals rt, the famous distance equals rate times time equation. We understand that distance equals rate times the time. And then up here, what we need to do is, let's highlight here, we need to solve for t. And t's right now, it's being multiplied by r. Okay, so what we want to do is do the inverse here. So let's divide both sides by r. All right, r divided by r is 1. And we get distance divided by the rate is equal to the time, t. Or in other words, t is equal to distance divided by the rate. You can switch the sides of the equation anytime you want. That's the same thing. Now that's solving for t. But on the left, let's have you try it now. Let's solve for r, not t. Okay? So pause the video. Give that a shot on the left side, right here on the left side. I said pause the video. Give it a shot. Don't just wait for me. All right. Hopefully you did your best. Let's take d equals RT. And let's solve for r now, the variable r. Now, r is being multiplied by t. So I have to divide by t to cancel that out and isolate my variable. And I get distance divided by time now equals r, or r equals distance divided by the time here. Again, you can switch the sides of the equation anytime you like. All right, so we're starting to get a feel for what's going on now, and but it takes a lot of these and a lot of experience to get really good, because there's all sorts of equations from science, physics, chemistry, biology, astrophysics, engineering, which involve formulas here other than just the field of mathematics that you have to get used to, depending on your stress and what you want to do. So on this next one here, this comes from geometry. This is the perimeter equation dealing for a rectangle. The perimeter of a rectangle is 2 times the length plus 2 times the width. All right, and we want to solve for L, which happens to be right here. Now you have to understand that it's being multiplied by 2, all right, and added to 2w. So what most people do, and what I suggest, is always add the opposite of the term to isolate your variable first. And the inverse of adding 2w, well, that's subtracting 2w. So let's do that on both sides. Notice all the action here in red, so it stands out. That's why I asked you guys to take out a red pen. Take good notes, do it in color, and you're going to be much better off until you get really good. The opposites here cancel to 0. P minus 2w cannot be combined because they're different variables. They're unlike terms. So you write it as you see it. P minus 2w from left to right is equal to 2 times the variable L. And I said 2 times L, not just 2L. Why? Because you have to do the inverse again, which means you got to divide both sides by 2. Show the canceling. And here you have P minus 2W. P minus 2W all divided by 2 is equal to L. Or if you want to switch sides, L is equal to P minus 2W divided by 2. Same thing. So now what I want you guys to do on the left-hand side is solve for the other variable W. Okay, so give it a shot. So we have P equals 2 times L plus 2 times W, right? So let's add the opposite, or subtract like we did here. Subtract 2L on both sides. Oh, wait a minute. Pause the video. Did you do it on your own? Pause the video and give it your best shot. All right. Now hopefully you gave it your best shot. Let's cancel out those like terms. P minus 2L cannot be combined. They're unlike terms, and that's equal to 2 times W. We're going to divide both sides by 2 again and simplify, and you get P minus 2L divided by 2 equals W. Okay? That's what you get from this. All right. The other response was this one right here. This was our response. Just highlight them all. Ooh, that sounds good, like bubble math. Okay, there we go. All right. So we're getting some experience, but that's not enough, right? So let's do it again. This one comes from geometry too. We got area is equal to 1/2 times the height. Notice I said times the height times the quantity B1, which stands for base 1 times base or plus base 2. This is the trapezoid area formula from geometry. All right, and what do we want to solve for? Let's highlight that. We want to solve for B2, and B2 is inside the quantity here. So you have a choice. You could distribute through these terms, do it that way, and you'll get an answer, which would be okay. Or you can start canceling out right now, and what I like to do is multiply by the reciprocal on both sides. And the reciprocal of 1/2 is 2. So if I multiply both sides by 2, I can cancel out the reciprocals, no problem. I can get 2 times A is equal to 1h, or h, times b1 plus b2. Now resist the temptation to distribute, because you don't have to all the time. This is h times something. right? So instead of distributing, you don't have to, you can simply divide. It's easier. All right, simplify. And so you get 2 times A divided by H is equal to 1 times B1 plus B2 is just B1 plus B2. Don't use the parentheses, don't need them anymore because you're multiplying it here by the 1. And we're solving for B2, this variable here, so all you have to do is subtract B1 on both sides. Right here, and what do you get? Well, let's see here. From left to right, you get 2A divided by H minus the B1, these cancel, equals B2, and you're done. Or if you want to switch sides, B2 is equal to 2A divided by H minus B1. All right, there you go. All right, and now what do we have? Well, let's see here. Let's take a look at this one right here. K equals 1/2 mv squared. This one comes from physics. K stands for kinetic energy, M stands for mass, and V, well, guess what? That's velocity. So you guys probably saw this too in your science classes. So when you're working with K equals 1/2 mv squared, and you want to solve for M here, the mass, oh, that one right there. All right, you first have to cancel out the fraction, just like you did above. And in the previous example, we multiplied by the reciprocal, which is 2. Well, let's try it again. Times 2 here, times 2 here, and cancel these guys out. 2 times 1/2 is 1. So you get 2 times K is equal to mv squared. And mv squared means m times v squared. So using the inverse function, we divide by m. Scratch that. Divide by v squared. Divide by v squared here. And simplify a little bit here. V squared divided by itself is 1. And you get 2k divided by v squared equals m. 2 times k divided by v squared equals m. Or if you want to switch sides, m equals 2k divided by v squared. Either one's acceptable. Same thing. Now I challenge you right now, before you get to the last one, to solve for the other variable v. So over here I want you to solve for v. Okay, v is right here, right there. Okay, pause the video and go for it. Okay, we're back now, and hopefully you gave it your best shot. I'm going to first cancel out my variables, or my constant here, times it by 2. That's a good idea. Let's learn from the previous one. So you get 2 times k is equal to m v squared. I want to solve for v this time, so I'm going to divide both sides by m. Simplify. So I get 2k divided by m equals v squared. And if we remember what we did earlier, right up here, when we solve for c squared, we square rooted both sides. Well, we're going to square root both sides here too. So square root the left side and the right side. And the square root cancels out the square, and that gives the square root of 2k divided by m is equal to v. Sweet, we're almost done. All right, now the last one here is the famous temperature equation. C stands for Celsius and F stands for Fahrenheit. And this is the equation we use in science to convert one temperature to the other. And in our case right here, we want to solve for F, Fahrenheit. All right, so let's go ahead and do some work. Let's bring it over here. All right, and we got C is equal to 5/9 times F minus 32. All right, first step. We can distribute here first, although I wouldn't do it. I would multiply by the reciprocal personally. It's easier that way. Reciprocal of 5/9 is 9/5, so times, and then multiply by the reciprocal here. Notice the dot, the multiplication dot. So what do I get on the left? I get 9/5 times C is equal to 45 divided by 45. This is 1 right here. And 1 times F minus 32 is just F minus 32. Now to solve for F, it's easy now. All you have to do is add 32 to both sides and you're done. Make it look easy because it is. As long as you understand inverses. So 9/5 times C plus 32 is equal to F, because these cancel out, right? Or F equals 9/5 times Celsius plus 32. That's how typically most people write it. Okay, and that's how the game is played. Now to get used to this, you got to do a lot of these, okay? And that's why, everything involves homework. And so, in doing your homework here, let's see here. We're talking about this right here, your little equations homework. So we have some examples here in first, and then we have a bunch of practice problems. In fact, we have about 44 of them. And then on the back side, this is called the key, guys. This is the answer key. These are the answers. So make sure that you check your answers as you go. So when you're practicing these, like this one here, for example, or this one, these are good ones. Circle the following, guys, and do these for sure. This is a good one that you need to work with. This one here. We just did this one. This is another good one. That's a good one, 28. That's another good one here, so circle that one. Ooh, this one's finance. This one's a good one. Ooh, that's pre-calculus. That's geometry. Circle the following problems. We did this one here. That's an engineering problem right there. Do number 19. Do all these and check as you go. Check as you go, and ask questions when you get back. Okay, so do your homework right here. Do your practice. If you want more examples, there's plenty of more examples right here. Here's another one. So you start here, all right, and get to here. Okay, that's another way to do it, by the way. So go ahead and give it your best shot. Practice and check. See me in class. And remember to always go back to your basics. Use your notes. This is a video too, by the way, so pause and play, rewind. Go ahead and listen to anything you need to again, and give it your best. And I'll see you in my next lesson. This is Mr. Aynes. We're signing off. Bye-bye.